Yeah, warm good morning to all. In the last lecture series, we have seen about heat treatment. In this lecture series, we are having a continuation of this heat treatment. In last lecture series, we have seen about annealing and its process. And now we are going to see about the second heat treatment, which is predominantly used in many industries, is normalizing. So, normalizing is a heat treatment process used to improve the mechanical properties and the machinability of steel as well as other ferrous alloys. So this process involves the heating of a material to a temperature above its critical range and holding it to a temperature for the sufficient time to allow the transformation of its microstructure and then cooling it in air. So the purpose of normalizing is that first one is refine grain size. So normalizing often is used to refine the grain size of a steel, resulting in improved mechanical properties such as toughness and strength. Second one is stress relief. It helps in relieving the internal stress that might have developed during the previous manufacturing process, such as forging, rolling, or even welding. And the third purpose is that it is homogenization. The purpose ensures a uniform and a consistent microstructure throughout the material. The fourth one is improvement of machinability. Normalizing steel often exhibits better machinability due to more uniform and refined microstructure. So the steps in normalizing is the first one is heating. So the steel is heated to a temperature typically between 750 degrees Celsius to 950 degrees Celsius depending upon the alloy composition, which is above the transformation range. The second one is soaking. Uh, uh, the second one is soaking. So the material is held at a temperature for a period or two periods sufficient to achieve uniform austenitization, allowing the carbon and alloying elements to dissolve uniformly. The third one is cooling. The material is removed from the furnace and allowed to cool in open air or still air. This slow cooling rate transformations the austenite to a finer perlite and ferritic structure. So the main thing is that when we compare this normalizing with other heat treatment process, when compared to unlining, the main two things in normalizing is that one is cooling rate. In normalizing, the cooling rate is faster because it is air cooled, whereas annealing the material is usually furnace cooled, so resulting in softer and more ductile material. The second one is grain size. Normalizing typically produces a fine grain structure compared to annealing. So in this compared to annealing, the second one is in quenching process. In normalizing, the cooling media in quenching involves cooling in water, oil, or another media to achieve the martensitic structure, which is harder and more brittle than the structure obtained from normalizing. And in mechanical properties, quenching increases the hardness and strength but reduces the toughness, while normalizing provides a balanced combination of strength and toughness. In application point of view, for normalizing, the structural components used for components that requires a fine uniform grain structure, good mechanical properties such as beams, rail tracks, and pressure vessels, and in pre-treatment for hardening often used as a preliminary heat treatment before hardening process to ensure uniformity and reduces the risk of distortion. In welder structures, apply to the welder components to leave residual stress and improve the uniformity of the welding. In microstructure changes during normalizing, the steel transforms from its existing microstructure, which could be perlite or ferrite or bainite or martensite, depend on the previous state, to austenite when heated to the critical temperature. Upon cooling, this austenite transforms into a more refined mixture of ferrite and perlite, which enhances the overall property of the material. So, normalizing is a crucial step in the production of high quality steel components, ensuring they meet the necessary specification of material mechanical performance and reliability.